Related to plumbing, I asked you, is there any requirement of an engineer in the plumbing? If yes, because everybody was suggesting yes, there is a requirement, then suggest me what will be his job, what he need to calculate, or else what he need to design. See, particularly I'll tell you, the name itself will be like plumbing design engineer. What he need to design, just tell me. Or else what he has to do in this particular industry. The number of pipes, outlets based on number of pipes, inlet, design of pipe, thickness, length, etc. Fine. Then she is saying that is pipes. Then any other suggestions from here? Only for pipes arrangements. Okay, fine. We'll do one thing. It will be an interesting session. Fine, thank you. Thank you. Sewage and water tanks, very good suggestion. Calculate the flow rate of fluid. Fine. Very good, very good. All the suggestions are good. Now, let me explain. For that, what we will do, we will consider a building itself, and for sometimes, like for 10 to 20 minutes, we will perform like a plumbing design engineer. Let's see what all the things we are going to do here. Fine. So what I will do, I'll share my screen itself. Hope this one is visible to you. Isn't it? Hope this is visible to you. Yes, fine. Now, see, imagine we are the plumbing design engineer now, and now we have a project from our client, and we need to calculate, or else how which system, or else what is the actual thing, practically what we are going to calculate, or else what we are going to design for a particular building. For example, our client, he has given, or else our architect, he has provided a building to us. Building in the sense, still they have not executed, but they have provided the plans, architect's plans, or else civil engineer plan. He has provided. The plan is of a residential type of building. Imagine this is a floor. This is a single floor. It's a residential type of building, and that building is of, okay, let me mention it here. System is hanging sometimes. There is okay. This, see, we have a building. See, we have a residential type of apartment. Consider it's an apartment, and that building is of G plus 10. G plus 10 in the sense ground plus 10 number of floors are there. Get it? And ground floor is for parking. Then rest 10 number of floors are there. Fine. Now imagine this is a single floor in which we have 4 number of flats. We have 4 number of flats in this particular floor. See, I have considered out of G plus 10 building, I have considered a single floor, and in that particular floor we have 4 number of flats. We will name the flat as provide the names for the flat as flat A and flat B and flat C, and this is flat D. Now once again let me explain. We have received a project from our architect or client, like it's a residential type of building, apartment, and the building is of G plus 10, and we need to calculate related to this 10 floors. Getting? And in each floors we have 4 number of spaces. Getting? In each floors we have 4 number of flats. One is flat A, B, C and D, and in each flat we have number of occupants like number of occupants we have 5. So in each flat we have number of people they are going to accommodate in this particular flat, which is of 5. Hope this is visible to you. Now see, I just consider the number of people, number of persons for this particular flat, which is of 5. Simply I have considered, but see, in actual condition we have to get this number of occupants. See, we have to get in the sense, for example, simply I'm suggesting you, okay, let me go to that whiteboard once again. This was our whiteboard. Here, see, first thing, being a plumbing design engineer, we need to calculate the number of people for a particular building or else for a particular space. If we need to calculate something related to that in plumbing, getting, for example, consider your own seminar hall, and that seminar hall is having a square feet area of 800 square feet. Then see, before constructing the building or else before constructing the seminar hall, if I ask you to calculate the number of people, how we will calculate the number of people? Because we don't have any information related to that. For that, we have 2-3 ways. In order to calculate the number of people, we have 2-3 ways. One is we can get the furniture plan from our architect. See, related to this furniture plan, building plan, floor plan, or whichever it is, we are going to deal later before starting our actual HVAC design. Getting, you don't need to worry about that. Now, once if we get that furniture plan, then each and every furniture will be clearly listed in that plan. Getting, so each and every furniture is clearly listed in the sense it will be like constructed a seminar hall and all the furniture is being provided to the seminar hall. Or else, let me explain you very clearly. Okay, everything has been constructed, a building or else your college building has been constructed. Then if I ask you to calculate the number of occupants in a classroom, then immediately what we can do, we can consider our classroom furnitures, isn't it? How many number of furniture, seating arrangements or sitting furnitures are there? We can count that easily, and including our lecture space, we can say it will be 60 or 61 number of occupants or else number of people they are going to accommodate in that particular classroom. Same way, if we have furnitures in this particular seminar hall, which is there in your college, then easily you can get the numbers, isn't it? Number of people by counting the number of furniture itself. Here, before constructing, we don't have any information related to furniture. So that's the reason I told you. First of all, we have to get the furniture plan from our architect or client. Then we can say, okay, this is what the number of people for this particular space. Because all the furnitures will be listed in the plan itself. What we have to do, we just need to count the plan, that's all. Otherwise, if you don't have any information, by making use of our common sense, always we have to consider minimum of 20 or 25 square feet per person. For example, if I ask you to calculate the number of people, number of occupancy for your particular seminar hall, which is having an area of 800 square feet. See, for example, I am considering it as 25 square feet for a single person. Getting, I'm just considering 20 or 25 square feet for a person. Then what will be the number of occupants here? Which is nothing but 800 divided by 25. We are going to get the number of people they are going to accommodate the particular seminar hall. Getting, so how much it will be? So that will be 32. Getting, so that is 32 number of people. See, it might be more, it might be less, because we don't have any actual condition. Simply we have considered something like 20 or 25 square feet for a single person. Sometimes it can be 15 square feet also for a single person. So if we are considering 25 square feet per person, then the number of people will be 32. Get it? Then, same way, imagine we have a residential building, and in that we have 2-3 bedrooms, and one bedroom area is about 300 square feet. Then considering 25 square feet per person for that particular bedroom, then what will be the number of occupants here? Suggest me in the chat box. What will be the number of occupants here for this particular? Yes, you can suggest me. So everybody is telling it is 12 number of person, but practically this one is wrong, isn't it? Because our room space is nothing but that is a bedroom space in a residential building, isn't it? And from our common sense, if we apply our common sense, it is not, there won't be 12 person inside a bedroom, isn't it? Isn't it? So this is how always we have to apply our common sense while designing, even it is HVAC or else electrical or else plumbing, whichever it is, it should be always we have to apply our common sense. Getting here, this is not the case. See, this is how, if you consider now, our architect or client, they'll kick us. Fine. So it is generally it is known. If it is a bedroom space in a residential building, then always it can be 2 plus 2 or else 2 plus 3. That means 4 or 5 number of occupants will be there, which is nothing but 2 adults and 2 kids will be there. Or else 2 plus 3 maximum in Indian condition. So this is how we need to consider the number of occupants. Getting? So a plumbing design engineer, what he need to do? First of all, he need to consider the number of people for a particular building. Here, see, in a single floor, we have 4 number of flats. I have given some information. How many number of people will be there in each flat? In each flat, 5 number of people. In the sense, in this particular floor, we have 20 number of people. Same way, if you calculate the number of people for this particular building, see, building is of G plus 10, isn't it? Then 10 multiplied by 20, how much it will be? How much it will be? 10 multiplied by 20, it will be 200. Isn't it? 10 floors we have. In each floors we have 20 number of people. So that you can say it as 200 people. 200 number of people will be there. How 20? See, Srikant, 20, I have given the information here, isn't it? I have given the information here, which is a G plus 10 residential building and G plus 10 building. In that, each floor having 4 number of flats, flat A, B, C and D. In each flat, we have 5 number of occupants. Each flat we have 5 in the sense, per floor we have 20. So for the entire building, 10 multiplied by 20, that is 200. Get it? Now we have calculated the number of people, basic requirement for a plumbing design engineer. Same way, see, one more thing I wanted to tell you. For HVAC design, our codes and standards are ASHRAE and ISHRAE. For electrical, NEC, IS and BS. Same way, for plumbing, we have taken out of this. Plumbing codes and standards are IPC, then UPC, UPC, then NPC and NBC, which is nothing but IPC in the sense International Plumbing Codes, then UPC in the sense Uniform Plumbing Codes, then NPC in the sense National Plumbing Codes, then NBC in the sense National Building Codes. Getting? Make a note of that. This might be an interview question. What are all the codes and standards we are using for plumbing design? It's nothing but IPC, UPC, NPC and NBC. See, from this, we will get the minimum requirements related to plumbing design. Get it? So, by making use of our Uniform Plumbing Code and National Plumbing Code, we have a suggestion from our, what is UPC in the sense? Yeah, fine. See, IPC in the sense International Plumbing Codes. UPC in the sense, that is Uniform Plumbing Codes. Then NPC in the sense, that is National Plumbing Codes. NBC in the sense National Building Codes. Fine. International plumbing codes, uniform plumbing codes, national plumbing codes, national building codes. See, in this, from this, we are going to get the minimum information, minimum required information related to a plumbing design. See, so as a plumbing design engineer, for that particular G plus building, we have calculated the number of people. Second thing, we need to calculate the water requirement. Getting what we need to calculate? We need to calculate the water requirement. See how to calculate this water requirement in the sense from UPC, by making use of UPC and NPC, National Plumbing Code, we have a minimum information. See, always if it is a residential building, then we need to consider 200 liters per head per day. So it's a standard. Then see, if I suggest this now, what I am suggesting from UPC and NPC, we have that information. For a residential type of building, always you have to consider minimum water requirement as 200 liters per head for a single person in a day. Getting? See, if this is the case, then we might be thinking, say 200 liters, it is more, isn't it? Sometimes we may feel that it is more, but in a residential type of building, see, we'll be using the water for our shower purpose, isn't it? Then our water closets, wash basins, kitchen sink, then floor trap, because floor cleaning, washing our clothes. Sometimes if we have a vehicle, we'll wash our vehicles too. For gardening purpose, we'll be using the water, isn't it? We are using the water for these many purposes. And out of that, one more information. See, always nowadays we have European type of water closets in each and every building, generally, or else mostly we can say. Once if you are flushing the European type of water closets, then we are going to waste 8 to 10 liters of water each time. We are going to waste 8 to 10 liters of water based on the flush arrangement. So imagine how many times we use water closets in a day. Then you can consider this 200 liters is more or less. See, still if you feel it is more, then standards suggest that 200 liters should be there. But if you don't have any water sources for that particular building, then what we will do? See, we have to adjust with the water availability, isn't it? Sometimes it may be 100 liters only, or sometimes it might be 150 liters only. But we cannot say that is comfortable for the humans to live in related to water requirement. That is the reason I have considered, or else from standards it is 200 liters per head per day. From an unoccupied residential building, how do we decide the water consumption per person, as the number of people residing is uncertain? See, Mahima, this is the reason I told you. See, number of occupants. See, in the sense, we are going to calculate the water requirement for the whole building, whatever, either before constructing or else after construction, whichever it is. See, from our furniture plan, we will be getting the number of occupants for that particular building. They are going to accommodate in the next year or in the future. Always, see, we have to consider the maximum. That is the reason I told you, number of occupants we can get from the plan. Once if we get the number of occupants, then we have minimum information from our UPC or NPC that we have to use 200 liters per head per day. In the sense, for example, see, I told you, or else we have calculated for this particular G plus 10 building, our number of people will be 200. Okay, we have calculated. Then as per your suggestion, in the first year only 100 people they are accommodating. Okay, they are accommodating in the sense, see what we will do, we will be providing the water, or else water will be available based on that number of people only. See, the reason why we are calculating water requirement is nothing but there is a motive behind that. Let me explain that. Fine. Now, see, if our water requirement per head per day it is 200 liters, then if everybody is accommodated in that particular building, then what happens? We can say the total water requirement for a single day, total water requirement for a single day will be 200 number of people are there. or else 200 number of occupants are there. That should be multiplied by from our standard. Our standard say 200 liters should be there in a day. So that is 200. So that you can say that will be 40,000 liters per day. So per day there should be 40,000 liters of water available for that particular building. In the sense, if see from our minimum information we have calculated the number of people as 200. If this 200 people are accommodated that particular space, then this 40,000 liters should be there. See, 40,000 liters should be there in the sense there should be some provision for that. There should be some tank in order to store that, isn't it? Then, as per Mahima's suggestion, once again, yeah, fine. Now, Mahima, she was suggesting like before accommodating that building itself, how come we can calculate? See, based on our minimum number of occupants, they are going to accommodate that particular building. Based on that, we need to calculate our water requirement. Because based on this daily water requirement, we will be calculating the rest of the things as a plumbing design engineer. See, if only 100 people are accommodated in the first year, then you can say it is 20,000 liters only. That is what the requirement in that particular year. But in the second year, 200 people are accommodated. Complete building has been accommodated with occupants. Then what happens? 40,000 liters should be there. That is the reason always we are considering the maximum. Getting? Now, see, here comes the actual requirement of a plumbing design engineer. What we have calculated, we just calculated the number of people and daily water requirement. Hereafter, see, if we get this daily requirement for that particular building, that is 40,000 liters per day, then where we will store this water? That is the big question. Then here, he need to work hard. A plumbing design engineer, he need to work hard. So that what he will do, he will be suggesting the client, we will go ahead with an OHT, overhead tank, and one more, we will construct an UGT. First of all, he need to see if he is suggesting one OHT and UGT, then he should say what should be the volume of water which we are going to store here. See, if we are suggesting only OHT is the requirement over there, then what happens? Do you think this 40,000 liters can be stored in OHT? No, because that itself will be a huge load for the building. Building won't withstand that. Isn't it? 40,000 liters of water. So that is the reason always the plumbing design engineer, they will suggest one OHT and one UGT should be there. If we are suggesting one OHT and one UGT, we have to suggest something, some more information like what will be the volume of the water which you are going to store in OHT, what will be the volume of the water which you are going to store. Before suggesting something about the volume or else something about the percentage of water which we are going to store in this particular OHT, see that OHT should be constructed. If it is readily available also, then in order to purchase, we have to suggest okay, this many OHTs we are in requirement. Getting? See, for this also, see, we have some values from our codes and standards. If we are constructing OHT and UGT, then standard says that maximum of 33% of our daily requirement we can consider or else we can store in our OHT, and in UGT remaining 67% we can store. But in actual condition, what happens? This 33% also we can't able to store, because see 33% of your daily requirement. Daily requirement is 40,000 liters, isn't it? If you calculate 33% of this 40,000 liters, then you can suggest me what will be the water which we are going to store in OHT, which is nothing but 40,000 multiplied by 0.33. So it will be about 13,200, 13200. That itself is a huge load for the building. So what plumbing design engineers they will do, they will not go ahead with this consideration, because maximum is 33%. So that they will consider the minimum, either like 10% or else 15% of the daily requirement they will be storing in OHT. So 10% in the sense it is about 4,000 liters, isn't it? Getting? 15 in the sense it might be 6,000 liters. That's all. So this is how they need to suggest their client. So if you are storing OST 20%, then you can say 8,000 liters should be. Okay, 20% in the sense, if you are considering or else if you are suggesting our client, only 20% we will store in our OST. Then 20% of our daily requirement, which is nothing but 8,000 liters. Okay, that is fine. If 20% here, then remaining 80% should be available in the sum tank. That is UGT. See, OST in the sense you can make a note of that. That is overhead tank. Then UGT in the sense that is underground tank. Everywhere it will be. But being a plumbing design engineer, our duty is to suggest this. Then second thing, our duty is to suggest the dimensions for this particular OST and UGT, because they need to construct that. OST, if you are constructing OST, then length, width and height, how much it will be. Same way, if we need to store 80% of our daily requirement, then what will be the dimensions of our UGT? What will be the length? What will be the width? What will be the height? That also we need to calculate. There is a sizing calculation in plumbing. Can you explain once again how can we take percentage of OST and UGT? See, I told you once again, let me repeat that. I told you maximum. See, from the standards we can go ahead with 33% of our daily requirement in OST and 67% of our daily requirement in UGT. But here, if you store 33% of your daily requirement, that is what 13,200 liters, then that might be a huge load for the building, isn't it? So in that case, what happens? The design engineer, they won't consider this, they'll consider the minimum. If you are considering 20%, then you can say 8,000 liters, isn't it? 10% of 40,000 in the sense that is 4,000, 20 in the sense that is 8,000. So 8,000 liters we will be storing in OST. There will be a space, and in UGT there will be a space to store remaining 32,000, that is 80%. Hope everybody understood now. Now we need to suggest what will be the OST size, what will be the UGT size. Same way, one more thing. So okay, we have constructed OST, UGT, or else they will be constructing. Then 20% we need to store here in the sense. Then from UGT to OST there should be a pump, isn't it? There should be a pump now. So next job for a plumbing design engineer, he need to suggest what should be the capacity of this pump. Capacity in the sense, either it is of 2 HP, 3 HP, 4 HP, 5 HP, whatever it is, he need to suggest. For that, there is a separate calculation for him, that is pump sizing calculation. He need to perform that pump sizing calculation. Then only he can suggest his client, okay, we are in requirement for 5 HP pump for this particular building. See, if he is suggesting that wrongly, for example, if the actual requirement is 5 HP, then if he is suggesting 10 HP, then in order to purchase 10 HP, the cost will be more, isn't it? So that is one thing. Our system should be cost effective also. Same way, if the actual case is 5 HP, then if he is suggesting 2 HP motor, then what client he will do? See, based on the plumbing design engineer suggestion only, he will purchase and he will install. Then what happens? Always the pump has to run. Pump running hour will be more, because only 2 HP instead of our 5 HP, they have purchased only 2 HP. So in order to provide this, in order to fulfill this requirement, always the pump has to run. Our electricity bill will be more. So many things are there in practical application. Always there is an engineering concept, but we people are not aware. In this particular industry I am talking about, getting